Good afternoon, you guys. I was going to go over just a couple more things in this section. I wanted to go over different ways that you can rewrite things in summation notation. I also wanted to talk to you about a sequence of numbers that are very useful and kind of you're never sure where they'll pop up, but sometimes it pops up in a lot of different places, so it's actually more useful than you might think. So what I have here is I'm just using Wolfram Alpha. So if you guys wanted to generate a sequence of numbers from something in summation notation, this is basically if I say what is I plus 1 times I over 2 for I from 1 to 10. So I is my index, and I want to see this expression for every value of I possible between 1 and 10 inclusive. And so when I type that into Wolfram Alpha, it interprets that in what they call the Wolfram language. So they're going to make a function called table. The first thing the table has is the expression. And then the second, after the comma, the second thing the table has is in curly brackets. It specifies the start and the stop of the range of numbers that you want I to have, and it will make a table that you see down below, where every value of I from 1 to 10, and then you see the expression for that value. So this is just some expression. So I want you to just see that. And you can see that you see the sequence of numbers. Now I could say, instead of showing me the table, instead of saying I want to see all 10 numbers where I has a different value each time, maybe for this example I'll go to a simpler expression. So I'm going to change this to, and you can even try this at home. I'm sure you want to. I squared. So, for every value of I from 1 to 10, what happens when I square it? So if I run that, you'll see I squared for all these values. From 1 to 10, these are the squares of I when I is between 1 and 10. So there you can generate the sequence. You just type the expression for then whatever your index was. You could use n or k, or you could put a word here. You could say, I wouldn't recommend that, but it might confuse it for what the word actually means, because this program tries to interpret what you're saying, and so I would use a variable. But in this format, it can you can type this too, but it will generate a sequence for you. Now, what if I don't want to just see 1, 4, 9, 16, all the squares? What if I want to actually sum up all the squares from 1 to 10, or 1 to 100, all the perfect squares? Well, I would just say sum that expression for I from 1 to 10. Sorry. And if I run that, it shows in summation notation I squared, I starting at 1 going to 10. It makes a nice little graph showing you each point. So that's the table. It's showing you as a graph. But it also, well, actually, that's not each I value. That's actually the sum. So this isn't just 2 squared. This would be 1 squared plus 2 squared. This would be 1 squared plus 2 squared plus 3 squared. And this would be more, 4 squared added to that. And when you square up all 10 and then add all 10 squares, you should get 385. So that's one thing I wanted to show you, that you can use this software to check your sums and to generate sequences. Now, Wolfram Alpha, I think, will limit you on how much it will show you, because it's free. You could buy the Pro version, or you could buy it. There's probably other software online that will do this for you. This is just what I'm showing you here. The next thing I wanted to show you was that when you have summation notation, there's a way that you can rewrite summation notation. So let me first show you the table again. So I'm going to take out the word sum. And so this is I squared, all the values of I squared for the first 10 values of the counting numbers. And then if I put sum in front, it'll sum them up for me. So if I sum from 1 to 10 for I squared, I would get all these numbers, added up. And you saw it was 385, I think. Lots of interruptions. What I want to show you is that when you sum from, you can rewrite this. So let's say I didn't want from 1 to 10. What if I wanted from 4 to 10? So it's only going to show me starting at 4 squared going to 10 squared. And I can sum that up. So I could say, well, what's that sum if I just go from 4 squared up to 10 squared? And I get 371. So not quite as big as before, but not super small either. We got the bigger ones. We got the bigger numbers in the sequence added up, and the ones that we didn't add were the lower ones. So we lost a little, but not a lot. But notice that this expression, if I go back to, whoops, if I change this back to 1, let's say, it looks like this. I equals 1 of I squared going to 10. But if I made that 4, notice how this expression changes. I equals 4 for I squared up to 10. So the only thing that changed was that lower index, the starting index point. So what I'm saying is that if you look at the table again, it's just a basic statement. It's that if I added up all these numbers from 1 to 10, the squares, it's going to be equal to if I add the squares from 4 to 10, these numbers, if I add these, plus if I add these, I'll get the full sum. So you can change things the way you write them in the summation notation. Let me use a slightly different program. This is a website that allows you to create math notation, graphics. So I'm going to go to this sum. And when I click that, it gives me, you see the preview down here. But it says, this is a markup language called LaTeX, L-A-T-E-X. The X is pronounced like a K, so it's LaTeX. So sum underscore means the lower thing, and then the exponent means the upper thing. So if I put I equals 1, it goes on the bottom, as you can see. And at the top, if I put 10, you see it says 10 at the top. So that's how you can make this little notation. And if you click here, you can download this image and then use it. You can put that into Microsoft Word, or you can send that to me. If you want to make pretty math text that looks like it's from a textbook, you could use a tool like this to make an image. And then instead of doing things by hand, you could show an expression like this, and it will look nice. So what I wanted to show you was if we do that for I squared, 1 through 10, we saw that was 385. If I sum the squares up to 10, 1 to 10, I get 385. But if I sum the squares, so I'm going to do that again, but this time I'm going to go from 4 to 10. And what I can say right now is that, oops, I forget how do you do this. And is it this? No. Oh well, whatever. This isn't true. The sum of this 1 squared up to 2 squared plus 3 squared plus 4 squared up to 10 is not equal to just the 4. This was like 372 or something. But it is equal to that plus from 1 to 3. So if let me put those in opposite order. I could sum the squares from 1 to 3, and if I add that for the sum of 4 to 10, that's the same as a consolidated sum from 1 to 10. So you can, in this notation, break up your sum into 2 separate parts, but just know that this index and this index will be 1 away. You don't want to double count the same index. You can break that sum up into 2 separate sums, or you can consolidate 2 sums together into a single sum. So that's one of the things I wanted to show you. So, but just pay attention to the indices. This is adding all the I squareds from I equals 1 to I equals 10. This is adding all the I squareds from I equals 1 to I equals 3. So that's 1 squared plus 2 squared plus 3 squared. And this is adding 4 squared plus 5 squared plus 6 all the way up to 10. And together, they're the same as this. I hope that makes sense. I hope that's straightforward. I'll have one more video, maybe 2 more videos for you, and then that'll be it. I hope that helped.